In this video, we'll be diving into memory management in Node.js. Understanding how Node.js handles memory is crucial for building efficient and stable applications. We'll cover the fundamentals of memory usage and how to prevent common issues like memory leaks. Node.js uses the V8 engine, which has a specific memory structure. The main parts of this structure are the heap memory, the call stack, and the code cache. The heap memory is where objects, closures, and other dynamic data are stored. The call stack keeps track of function calls, local variables, and the execution context. The code cache stores compiled JavaScript code and optimizations. The heap memory is further divided into two generations, the young generation and the old generation. The young generation is where new objects and short-lived data are stored. This area undergoes frequent garbage collection. Objects that survive garbage collection in the young generation are promoted to the old generation. The old generation stores long-lived objects. Node.js provides several tools to monitor memory usage. The process.memoryUsage method provides detailed information about memory consumption, including the resident set size, total heap memory, used heap memory, and external memory usage. You can use the Node inspect flag when running your application to open Chrome DevTools, which provides powerful profiling tools for analyzing memory usage over time. Several common patterns can lead to memory leaks in Node.js applications. One frequent cause is unremoved event handlers, which keep references to objects alive longer than necessary. Unclean timeout and interval callbacks can also prevent memory from being released. Accidentally creating global variables and circular references between objects are other common sources of memory leaks. Let's look at an example of a memory leak caused by event listeners. In the incorrect code, an event listener is added to the server object but never removed. As a result, the server keeps references to the handler function and associated data, preventing them from being garbage collected, even after the server is no longer needed. In the correct code, the event listeners are explicitly removed using remove all listeners, and the server is closed using close before cleanup. This ensures that all references are released, and the memory can be reclaimed. Here is another example with timers which might also cause memory leaks. In the incorrect code, a timer is set using setInterval, but it is never cleared. As a result, the callback function and any data it references remain in memory indefinitely. In the correct code, the clearInterval function is used to clear the timer when it is no longer needed. This ensures that the callback function and associated data are released from memory, preventing a memory leak. To prevent memory leaks and optimize memory usage, follow these best practices. Always remove event listeners and clear timers when they are no longer needed. Monitor memory usage regularly using tools like process.memoryUsage and Chrome DevTools. Avoid circular references by using weakmap and weakset for weak references. Optimize object creation by pooling objects and minimizing allocations. You can tune the garbage collection process in V8 using several flags. The max old space size flag allows you to increase the heap memory limit, which can be useful for applications that require a large amount of memory. The exposeGC flag enables manual garbage collection, allowing you to force garbage collection at specific points in your code. You can manually trigger garbage collection by checking if global.gc exists and then calling it. To summarize, remember to monitor memory usage regularly with built-in tools, clean up event listeners and timers properly, profile applications to identify memory leaks early, and optimize object creation and garbage collection. By following these guidelines, you can build efficient and stable Node.js applications that effectively manage memory and avoid common issues like memory leaks. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.